problem number 8. And problem number 8 is 2954. Now we deal with circular wires. Half circle. And another half circle. And here is a point, let's call it point P, exactly at the center of these circles. And there is a current flowing in this direction, I. And this has a radius A, and this has a radius B. Well, if we again give these lines numbers 1, 2, 3, 4, then it's immediately obvious that 2 and 4 do not contribute to the magnetic field at B, because the sign of theta equals 0 in this cross product. So we only deal with 3 and with 1. Now 1 is going to give me a magnetic field which is pointing perpendicular to the paper in the paper. This is 1. But 3 will give me one that is in the opposite direction, coming out of the paper. So this one is due to 3. And this one will be stronger than this one because the radius is smaller. The current is the same, the radius is smaller, it is therefore closer to the wire, so the magnetic field will be stronger. So this will be the winner, so finally the magnetic field will be pointing upwards. Well, what I propose to do is to simply calculate for you the magnetic field of one arc, and then I'm sure that you can do the superposition of both arcs. So here's one arc. I call this point A, and I call this D, and this is the center, this is P. I have a current I in this direction, and I have here a little element dl. I have here this vector r, and the unit vector r is in this direction. And let the radius of this circle be capital R. Well, what is interesting that every element dl, for every element dl, r is perpendicular to dl. And therefore, in all cases, is the sign of that angle theta is the same, 1. Whether it's plus or minus 1, well, it's a matter of taste. The dot product is dl cross r. Sine of theta, 90 degrees, is 1. If you want to call it minus 1, I don't care. I really don't care, because I do know that the magnetic field is in this direction, and that's ultimately all I want to know. All right, so I can delete the cross, and I can write down now what the magnitude of dB is, which is mu 0 times I divided by 4 pi. And I do now a very dirty integral from A to D along this arc of dl divided by r squared. But the integral of dl is simply 2 pi r. So what comes out of this is that this should be the integral of dB. So this is really B. It's the integral of all these elements. So what comes out at B, at that point P, equals mu 0 times I divided by 4r. And notice that it's inversely proportional to 1 over r. And that is very characteristic. You will never find an inverse r squared. Now, you have to do another current which goes in the opposite direction, and so you have to add the 2 factorially, And I will leave you with that. I don't think that that's going to be a problem at all.